Hey, welcome back, everyone. We're going to continue our conversation on systems. As we normally would do, I want to go over last night's homework that you should have already uploaded. If you look at some of these even answers, I showed a little bit of work with number 2. Nothing too fancy here, but you want to use a substitution method most likely. Make sure you always substitute with grouping symbols. In this case, that causes us to distribute the 3. Certainly watch out and be careful about that. Look at number 4. It's really a substitution problem, but if you're just substituting y for y, your equations are now equal. And you can go ahead and solve those for a pair of negative 2's. So what do you think? Anything that you need to talk about? Of course, you want to follow up with me. Each of these systems, at least with the numbers 2, 4, and 6, are consistent and independent, which means they have a solution and one solution. All right. Well, today we're going to continue talking about systems, but quite frankly, they're going to be systems that are a little larger. They contain basically more variables, which means that they're going to have more equations. So what we have here is a system where we're going to try to solve for x, y, and z. Just to make sure that you're seeing the correct numbers in these systems, the first one is x minus 2y plus 3z equals 12. Next one is 2x minus y minus 2z equals 5. And 2x plus 2y minus z equals 4. So what are we going to do? Well, the truth is we're going to do the same thing we were doing with the simpler systems, but we're just going to have to do a little more, and we're going to have to do it with some type of purpose. You see, the mistake that kids make is they just start randomly canceling or randomly substituting, and we just want to slow down a second and realize that when we're solving 3 variable systems, we want to have a method, we want to have a purpose. Now, you're going to either cancel or substitute. You could add the word substitute here, but a lot of times it's going to be the canceling that people do. But we're going to cancel or substitute in the name of 2 variables and 2 equations. What do I mean by that? Well, let me add something here. In the name of the same 2 variables is going to be important. So if I've got an equation with x, y, z, and I have another equation with x, y, z, and let's say that I cancel something in those 2 equations. Let's say I cancel the z. Well, that means I'm going to be left with x and y. All right. Well, what that means is the next time I cancel, I want to cancel in the name of getting x and y, which means I'm going to have to cancel z another time. Okay, so when you solve these problems, you have to understand that you're going to be canceling most likely twice, but you want to do it so you can get the same 2 variables. All right, so what do you think as we look at this system? One thing I'm going to suggest, at least from a teaching standpoint, is that if you label your equations, maybe the first one I'd label as equation A, maybe the second one is equation B, and the third one is equation C. Sometimes if you label them like that, it makes it a little easier for us to talk about them. Now, I see something in equations A and C. Do you see in equations A and C? Do you see that the y's are opposites? What that means is that if I add equations A and C, if I basically do the elimination method with equations A and C, I'm going to cancel z. I'm going to cancel z. Let's try it. If I add the top equation with the bottom equation, I get 3x. Of course, the y's are going to cancel. And if I add the top equation and the bottom equation for the z's, I get 2z. Now, be careful. You also have to add the constants, which means that I'll end up with 16. Okay, whoops. I want to get rid of some of these marks I put on here. All right. Now, I did this in the name of getting x and z. So that means I need to cancel again. Now, what that means is I want to add 2 other equations to also end up with x and z. All right, now that means I'm going to have to cancel y again. How am I going to cancel y again when they're not opposites? Well, I have to make them opposites. I have to make them opposites. Look at my second equation, b. If I multiply it all by 2, it'll now be the opposite of equation c. I'll end up with a 4x, I'll end up with a minus 2y, and a minus 4z, and that's going to equal 10. But here's the important thing. I now have y's that are opposites again. So I'm going to add equation b plus equation c. But note that equation b has been slightly changed, so I'm going to call it equation b1, just so we understand that it's like a changed version of equation b. Okay, what happens? Add your x's. That's going to be 4x and 2x. So if I add those x's, I get 6x. Add your y's. That means I'm adding negative 2y and positive 2y. We already got done saying that they're going to cancel. And add your z's. That's a minus 4z and a minus z. So that's going to be a minus 5z. Now don't forget to add your constants 10 and 4. And 10 and 4 will add to be 14. Okay. Now what I did was I canceled twice in the name of getting x and z, which really means I canceled y twice. Well, look what I made. I made a nice little system. It's a nice little system that I can solve like we did on our nice little day yesterday. How do you solve a nice little system like this? Probably with the elimination method, probably by getting some opposites. So what do you think? Do you want to make the x's become opposites? If you want to make the x's become opposites, you can multiply by negative 2. You could also make the z's become opposites. But I'm going to choose to do it this way so I can get negative 6x, negative 4z, and negative 32. Now I'm going to add these equations together, and of course I'm on my way to solving for my first variable. So I get negative 9z, and what do we have here? Negative 18. So that means z equals 2. Now, once I get my first answer, we're starting to hit that home stretch, but I want to continue to be careful because I'm going to take this answer, I'm going to carefully plug it back into my smaller equations. The reason I'm plugging it back into my smaller equations is so I don't have to mess around with all those big equations back in the beginning. So we're going to plug 2 in here for z. Obviously, that allows us to solve for x. Okay, looks like x is going to equal 4. Okay, now once I have these two answers, I have no choice but to go back to my first two equations. Excuse me, my first 3 equations. So if x equals 4 and z equals 2, then kind of take your pick. You can plug it back into any one of these equations up at the top. Okay, I did kind of make a mess out of these equations, but I don't know. I kind of like the last equation. The reason I kind of like it is because it seems to have the smallest numbers generally. So I'm going to plug into the 2x plus 2y minus z. And of course, I'm going to plug in my answer of 4. I don't have anything to plug in for y because that's what I'm solving for. And I'm going to plug in my z value right here, which was 2. We'll plug that in, and it equals 4. So we're just being careful about some back substitution. And if you solve this carefully, you get 8 minus 2, which is actually 6, plus 2y equals 4. And that means that y equals negative 1. So x equals 4, y equals negative 1, and z equals 2. What do you think? We're solving some bigger systems. Okay, a lot of this is realizing what you can cancel so you can be left with 2 variables. Of course, you want to do that so that you can end up with 2 equations with the same 2 variables. All right, now I know for most of us it's just a matter of trying this. This looks like the same problem, so I'm not going to try this one again, but this looks like a new one. So what do we got here? 2x plus 2z. That's a little hard to read. 2x plus 2z equals 2. 5x plus 3y equals 4. And 3y minus 4z equals negative 4. Okay, now the way that this equation or this system is formatted is meant to help you realize that each one of these equations is missing a variable. Sometimes it can be helpful to rewrite your system so that the missing variable kind of has a blank space. For example, in this first equation, I'm missing the y, so I'm going to kind of leave the y space blank. In this next equation, I'm missing the z, so I'm going to kind of leave the z space blank. All right, and then the last one, I'm missing x. Now that might or might not make things easier for you. I'm just saying that some people like to do that. They like to kind of rewrite it with those blank spaces. Now, take a look, because every one of these equations has two variables. What that means is that I only need to cancel one time. And I just want you to notice right here in the middle, these y's. They're almost opposites, aren't they? They're almost opposites. How can you make them opposites? Well, real simply by throwing a negative sign on one of them. Of course, if I throw a negative sign on one of them, that means I have to multiply all of them by a negative 1. Okay, now what that does is it allows me to add the second equation with the third equation. What happens when you add them? You're just going to get a 5x. Don't forget about the 5x. The y's are going to cancel. I'm going to be left with a 4z. Okay, now over here, I have to make sure that I add 4 plus 4 and get 8. I almost forgot to do that and was just going to write down the number 4. Look at what we have. We have an equation with two variables, x and z. If you look up at the top, we also have an equation with two variables, x and z. What I'm trying to say is that you can now take these two equations and you can put them together as your smaller system. Okay? I didn't have to do it twice because I already had an equation that I could match with this. So now what? Do you realize that you're back to where we were yesterday? You're just back to solving using basic strategies. You know, if it was me, I would make this as easy as possible. Multiply by a negative 2 so that you can make those z's be opposites. But of course, you're going to get negative 4x as well as negative 4z and another negative 4. Okay. Now, it's up to you. If you want, you can kind of get rid of an equation that you're not really using anymore. You know, I don't know if I would really fully erase it, but we want to make sure we understand that we're adding the gold and the green equation. When we add the gold and green equation, the 5x and negative 4x give you x, the z's cancel, and the numbers add to be 4. Well, there we go. We have our first answer, x equals 4. All you got to do is plug x equals 4 back into one of these equations. I like the gold equation. How about you? And when you plug 4 back in, you can solve for z. Obviously, we're going to get 20. We can subtract 20 from both sides, and that'll give us negative 4, or excuse me, negative 12. Now 4z equals negative 12, so z equals negative 3. Interesting about this particular system, because the nature of the system was that we only had two variables in every equation, I could right now just plug in one of these numbers, you know, like maybe this 4. I could plug this 4 back into my second equation, and I could certainly go find y. So I like that. I'm going to plug 4 in there beside 5. It's going to give me 20. And when I continue solving that, I'm going to have 20 plus 3y equaling 16. Was that 16? Shoot, 4, my fault, equals 4. And then when I start solving this, I'm going to get 16. I'm actually going to get negative 16, but we'll subtract 20 from both sides. Now, comes out to a decimal. Sometimes people think that means they made a mistake. No mistake, you're fine. If you want to turn it into a decimal, negative 5 1/3, you can also leave it as negative 16 thirds. But the truth here is that we have our three answers for x, y, and z, which you may have noticed that the first time I did this, I wrote it as an ordered pair. It's actually an ordered triplet because we have three numbers. Is that still a point? Like, how do you graph the point 5 negative 5 or 4 negative 5.33 comma 3? Well, it's a three-dimensional point, and it's hard to do three dimensions on two-dimensional paper. But if you can kind of follow my sketch here, this is the x-axis, this is the y-axis, and this is the three-dimensional z-axis. So, I could move 4 units in the x, I could move down negative 5 units in the y, and then I could move out 3 units in the z. And really, I would have a point that's out in space. I can't really plot it on this two-dimensional surface. But it turns out that 3 planes, 3 surfaces, they actually do intersect at a point. And what we're trying to say is that that's what you found in this problem. You found the intersection of 3 planes. Again, they do intersect at a point. But they can also intersect in many other ways. They can intersect in the manner that only 2 of them intersect at a time. This is another way that 2 of them can intersect at a time. Here they all intersect, but they intersect like as a line. And this one is truly the no solution. They don't intersect at all. The only type that we're going to do is going to be this one that I'm showing you where they intersect at a point. Because if you're going to work through one of these problems, then I want the answer to come out correctly for you. Now, if we were in class, the next thing we would do is I would give you this exit ticket. We're not in class in person, but I'm still going to give you this exit ticket because I want you to try one of these. I want you to get your hands dirty and work this out. It's very doable. In fact, if you've just looked at the problem, you may have already noticed that the z's are opposites. That's because I want you to add those z's together. Or excuse me, I want you to add the first 2 equations together. What will you be left with when you add those first 2 equations? That's right, you'll be left with an x and a y. Well, look, your third equation is already an x and a y. So you're halfway done the problem. Okay, so you're going to cancel the z's in the name of x and y. And then you're going to match that up with that other x and y equation. You can get this right. You're going to get it right. I want you to upload it as part of your today's assignment. You can either upload it separately or you can upload it with your homework. Of course, after you do the exit ticket, then you do want to work through the homework. I tried to make it a little shorter since the problems are a little harder to do. And we'll see you next time.